So hello guys, today I'll be explaining you about 9 major architectures of microservices. Before jumping onto that topic, I want to explain you about how payment gateways basically works from customer to the bank. Let's take an example. When we order something from an e-commerce website or any product based website, we get an option of like pay with the cash or pay with the card. So pay with the cash is an easy option, and the other option is pay with the card. So who take care of this cards payment? If anything is stuck between the payment, who take care of this? So when customer made a payment of this, now it will go to the merchant. Who are merchant? Merchant are those basically who are selling their product on their websites. Now they will request a payment that my customer has uh, requested an order, and I want to confirm the payment so that I can further proceed like to the customer that your payment has been confirmed. Now your order will be received in some days. So now merchant will directly go to the payment gateway. Payment gateway are basically a third party apps. It is basically an alternate payment method. They are third party app. If something is stuck, like many time happens, like when we do a payment got stuck in between, we get we see a message like this much of money has been deducted from your account, but order has not been completed yet, order has not been approved yet. So who take care of this? Merchant is not going to take care of this, because why will he take the responsibility? So payment gateways are the third party app who will take care of the responsibility. They say I'll take care of your responsibility, you don't have to worry about this. They say the e-commerce doesn't have to worry about this, the merchant doesn't have to worry about this, I will take care of this. I will directly contact to the bank and the bank will issue the payment. After that, they directly process their payments, and the payment processor will directly connect to the card network. You must have seen various type of cards like credit card, debit card. You must have seen like Visa card is there, Mastercard is there. So they all are basically a card network. That network will directly connect to the bank. They will tell my third party apps are requesting a payment for their customer, so I want you to approve this much of payment, please approve it. So now bank will issue that much of payment. After that, the card network will receive that amount of payment. He will check that funds transfer has been completed, funds settlement has been completed, merchant account has been completed, it has been transferred to merchant account. Before going into that merchant account, it will go to the payment gateway. Now payment gateway will check transaction has been authorized, it has given me the result, it has given me the payment confirmation. Now finally it will go to the merchant. After that, it will go to the customer will see an option like your payment has been received, your order has been confirmed, you will receive your order in an this much days or in an upcoming days. So this is basically about the flow diagram of the payment gateway, how payment gateways work. So from customer to merchant, merchant to payment gateway are basically alternate payment method. These are the third party apps who are basically responsible for all the payment issues, payment type of issues. If something is stuck or your money has been deducted from the customer account, they are responsible for that. After that, payment processor, after that, card network, after that, bank will issue the payment. Now the payment is completed. This is how basic payment structure look like. Now moving on to our next thing, that is what kind of technology are used to create these payment gateway. So we basically have two major technologies, that is monolith, and other one is SOA, that is service oriented architecture. I'll be explaining you about in an upcoming slide or maybe next time. So SOA is majorly used by most of the developers. Most of the payment gateways are made on this SOA, service oriented architecture. So let's move on to our next slide, that is componentization via libraries. We have to understand it very clearly. Let's suppose this square that I have made, it's a payment gateway where all the payment thing will be happening, like the validation will be happening, the processing will be happening, everything will be happening here, every code will run here, every security code, PayPal code, third party app codes, every code will run here. But we have an issue here. Like if we are working on an Linux, that is a third party app, if we are working on a Linux code, if we are working on a PayPal code, if we are working on a Stripe code, if we are working on a security code, any other code we are working, it will all run on a single port, that is 8080 port, or it can be other port 8888 port, any other port, but it all will run on a single port. Like if we want to change something on an Linux code, we will change it, but in the background all the three are running. So if we change something in an Linux and we want to check that we did it correct or not, so we will check, we will run it on an 8080 port, but other three will also run with us. So this will take so much of time. If we want to change something in a PayPal code, we will change. If we want to change in a Stripe code, we will change. If we want to change something in a security code, but if we want to check something particularly, like we want to check the Stripe code, we have changed something and we want to check, like if you change something, you should check that whether it is running or not. When I'll check, the Stripe code is running perfectly, it is running on an 808 port, but other code is also running. So they will take so much of space, they will take so much of time, so it basically make a lot of chaos. How someone can overcome this type of situation? So we have come with a solution, that is componentization via services. What we have decided, it's a payment gateway, this whole square is a payment gateway. In this we have taken two codes, like PayPal code we are doing, Stripe code we are doing. There can be any other codes here, it can be a security code, it can be any type of code, validation code, processing code, payment code. So what we have done here, we basically took an PayPal code, a single code, we will code it, and single code Stripe code, we will code it. It will run as a single process, it will run on a single port, it will create a single .jar file. For every code there will be a particular process, there will be a particular port, there will be a particular .jar files. Like if I changed something on a PayPal code, now I want to run, I want to check like my code is correct or not. So what I'll do, I will go on a 8080 port, my process has been completed, I'll check on port, yeah, it is running fine. I can say okay, now it is running fine. Now my code is running on this 8080 port. Now I want to change something on a Stripe code. What I'll do, Stripe code is running, we are running this Stripe code on another port, like suppose that 8888, we are running on 8888 port. So basically we get that these two particular codes are running on a different ports, so we will not get that much of chaos. Like if we want to run a single code, we will have to run all other codes. If we want to change something and we want to check something from the single code, all the codes won't be running. For every code there will be a single process, there will be a single port, there will be a single jar. This is how basically componentization via services works. This is the first architecture of a microservices. So there are basically three microservices: payment validation service, payment processing service, payment provider service. The first one is basically how, what is the need of in this, what business need, what is the demand of that businessman, what security they need, is he allowed to do the payment, Eh, is his card is allowed to do the payment. Any security basis thing or any business basis thing will come into the validation service. Next is payment processing service. Now when we order something and we are done with the payment, so when we are in the middle of the payment, we see the status of the payment, that is it has been approved, or it has been completed, or it has been processing. So the first payment is in process, then approved, then it completed. All these code will come in the payment processing service. After that, this is the code for the all the third party code will come into the payment provider service. These all three will run together, so it will make a payment gateway. Moving on to our next slide. So these are the 9 attributes. Componentization via service. I have some spelling mistake. Organized around business capability. Componentization via service I have already discussed. Now moving on to organized around business capability. So basically converting one form into major services according to the need of business. It it is basically when business need it, we will develop it. When business doesn't need it, we will not develop it. It basically depends on the business need. Next one is decentralized governance. So let's understand first what is centralized governance. So when we are uh, developing something, it may have some rule, it may have some language, it may have some tools, like we have to follow this much of security, we have to follow this much of rules. So if we follow that type of rules and that tool has been completed, it has been done, now we cannot do any changes to that tool. Now the tool will run for 10 years, for 20 years, we won't be able to do anything to that software, because it is a rule, it has been followed, it should be followed. So what we have decided with the decentralized governance, what languages should we use, what tools should we use, what practices should be there to follow in the given microservice. Next is decentralized data management. Every service particular database. Now what is decentralized data management? Let's understand. If we are working on three particular service, I have told you, like first one is validation, second one is processing, third one is third party, that is PayPal payment service. If we are working on any of the service, in previous year what was happening, like we have three services together. In that three services we have different services, we will discuss it later, but major is our three services. If we are working on three service, we will have a single database. Validation will also have a same database, processing will also have a same database, and the payment will also have a same database. Now validation wants something from their data, they will have to check the database of processing and the payment. Now if payment want to check their database, they will have to check their validation database also, their processing database also. Same goes with the processing database. The all three services data are saved in a single database. So how can someone overcome this type of situation? So we have came with decentralized data management. Every service will have a single database, like validation will have different database, processing will have different database, and payment will have different database. So we don't have to like go to their other database, or we don't have to wait that much to look for some data. Now if validation service want to check something from processing database, if validation service want to check something from payment database, how will they check? Validation service will make a call to the payment service. Now that payment service will tell their database, you can give your data to the validation service for only viewing it. You cannot change to their database. You can see what data is there and what is not there, but you cannot change. Same goes with the processing. If validation want to see the processing database, processing will give an order. Validation will have to first make a call to the processing will tell the database that give the data to the validation. He can only see it, but they cannot change anything to that database. Now if we had made a call through validation to the processing, the validation can see the database of processing, but processing service won't be able to see the database of the validation service. Why? Because validation service has made a call to the processing service, but processing service didn't made any call to the validation service. So processing service won't be able to see any data of the validation service. So let me show you a slide. So this is basically a service 1, service 2, service 3. You can call it as validation service, processing service, or a payment service. Every service will have a single database, like database 1 for validation, database 2 for processing service, database 3 for payment service. I have explained you. Next, we can say infrastructure automation. How you basically start a code. So when we make any kind of service, let's take a validation service. In validation service, we have different kind of services. We don't know now. It's a number of services are there in the validation service, in processing service, and in payment services. Let's take it as a validation single service. When we make a validation service, what are the steps to make that? We have to first make it as a project in ID. We have to make different branches, that is master branch, integration branch, feature branch. We have to put that into a bit bucket. We have to clone that into a local machine. We have to import them into a ID. We have to change the code. We have to replace new jar into EC2. We have to kill the existing service. We have to restart. We have to check logs and confirm services up or running. So this is the process for making one service. Now if we want, suppose this will take a 10-minute to make that service. Suppose it will take a lot of time, but suppose it is taking a 10-minute time to make that particular service. Now if we have to make 10 service, now we have to make 20 service, 30 service. It will take a lot of time that we cannot even imagine. It won't even work. So what it will do, here comes the role of scaling DevOps engineer and ALB, that is load balancers. So what basically it will do, let's see it through an example. This is the service that I have taken, validation service. I could have taken payment service also, or processing service also, but let's take an example as a validation service. So number of requests are coming. Now if we directly go to the validation service will be confused if it is a number of requests, that it won't be able to handle it. If validation service has a capacity of 4 GB RAM and the requests are coming for 8 GB RAM, that won't be able to handle that. So what we have done here, we have basically applied a load balancers, that is ALB. Now what it will do, all the requests that are coming, it will now go to the ALB, that is application load balancers. After that, the request will go to the validation service. Now what ALB will do, ALB will see that the requests that are coming, is validation service is able to handle that much of request, or is he able to handle that much of request, or he cannot handle that request. So what I can do, ALB will basically distribute that validation service into an instances. Take an instance as a copy of validation service. It will make a copy of validation service. So the 50% will go to the one validation service, 50% will go to the other validation service. How it will divide? If we have a single validation service of 4 GB RAM and the ALB wants to make an instance of an 8 GB RAM or a 16 GB RAM, so it will make an instance in which validation service will have a memory of 8 GB RAM, 16 GB RAM, it can be anything according to the need of the request. This basically is known as vertical scaling. When we have a single service that they are not able to handle that much of requests. Suppose this validation service 4 GB RAM is able to handle 50 requests, but the requests are coming for 100. So it has given us the instance in which we have a 8 GB of RAM. So now the 50 request will go to the validation service of 4 GB RAM, and the other will go to the validation service of 8 GB RAM. Or sometimes maybe all the requests will go to the 8 GB RAM according to the need of the request. It is basically vertical scaling. Now, what is horizontal scaling? We have seen the validation service is divided into an instance. We will produce the memory or we will enlarge the memory. Horizontal services basically it will create the same instance, the copy of that instance. It won't be increasing any size. Like it won't be increasing 4 GB to 8 GB. It will increase that validation service. It will make a copy. It can be a 3 copy, it can be a 4 copy, it can be a 5 copy according to the need. The ALB will make a copy, make a instance of the same validation service. Now if the request is coming for 100, 50 will go to the first validation service, 50 will go to the instance of that validation service. This is known as horizontal scaling. So you have understood what about scaling. So let's understand about WAF that I have written. That basically stands for Web Application Firewall. Now let's take this whole as a single payment. All the code is happening here. ALB doesn't have to do anything with this side of code, with this right side of code, that validation service, vertical scaling instances, horizontal scaling. ALB doesn't include this. Between ALB and this coding, validation service, payment service, processing service, we have a wall. When all the requests are going to these services, we have got some attackers, or you can say hackers, who might want to hack the system of payment gateway. So now what it will do, it will basically make a wall, or it will make a firewall, that is web application firewall. The major commonly used web application firewalls is HTTP. So it will protect attackers to attack these requests that is going to these services. It will basically protect these services. So that is the role of the WAF here, web application firewall. So moving on to our next point, that is products not projects. It is, you can check about this. Next one is design for failure. Now when we are doing our payment, we'll see that our payment is done or not done. We get an option like your payment has been success, your payment has been failed, your payment is timeout. When we get a timeout, we are worried like what is happening. Timeout is nothing, there is something happened in that, but that is not a failure. We have to wait for that thing. Next one is evolutionary design, and after that smart endpoint dump pipes. Now let's understand some basic disadvantages of microservices, some major disadvantages. If there are pros, there will be a con. So let's get it through an example.